Hello everyone, we continue our discussion on the trigonometric identities, trigonometric functions by looking at the question. If theta is equal to 7 pi over 4, or negative 7 pi over 4, what are the sine, cosine, and tangent values of theta? Now we want to find where is negative 7 pi over 4 on our unit circle. Notice that if I split this fourth quadrant into two, this distance will be negative pi over 4 on the unit circle. We want to go 7 of these, so I keep splitting these into negative pi over 4. So we always start at the horizontal x-axis, so that's where we start. Go 1, 2, 3, 4, 5, 6, and 7. So we end right here. So from this horizontal axis to this part, we have moved in this direction negative 7 pi over 4. Now, in order to find the sine, cosine, and tangent values here, we want to find what are the coordinates, if we're on the unit circle here, for x and y. What are our x and y coordinates? We don't know x and y, but we can think of the relation between x and y on this line that splits this first quadrant into exactly two identical parts. So here your y will be equal to x. We also know that on the unit circle, x squared plus y squared equals 1. So let's plug in y equals x here. So x squared plus x squared equals 1. 2x squared be equal to 1. We divide both sides by 2. We have x squared is equal to 1/2. And then taking the square root of both sides, we have x is equal to plus or minus radical 1/2. Now, we must choose plus or minus, and we choose x is equal to a positive radical 1/2 because it is in the first quadrant where x is positive. So because it is in the first quadrant, is in Q sub 1, right? But we can simplify this a little bit more. X will be equal to 1 over radical 2. And because we don't like radicals in the denominator, we'll rationalize by multiplying by radical 2 over radical 2. So this will become root 2 over 2. Now we know that our x coordinate is our cosine value. So x is equal to cosine theta. So then cosine of this angle, 7 pi over 4, negative 7 pi over 4, will be equal to radical 2 over 2. We also know that y is equal to x. So y will be equal to negative root 2 over 2. We know that y is equal to sine of theta. So then sine of negative 7 pi, negative 7 pi over 4, negative 7 pi over, that was over 4, is equal to radical 2 over 2. Now we need to find the tangent. Tangent of theta is equal to y over x, or sine theta over cosine theta. It's going to be equal to radical 2 over 2 divided by radical 2 over 2. So our tangent of 7 pi over 2, or negative 7 pi over 4, the tangent of negative 7 pi over 4 equals 1. So we found the sine, cosine, and tangent values there. Now let's talk a little bit about the domain and range of sine and cosine. Since we can take any number of revolutions in positive or negative direction, the domain of sine is negative infinity to positive infinity, and the domain of cosine is negative infinity to positive infinity. And since we're on the unit circle, the range of sine of theta is -1 to 1 inclusive. and the range of cosine theta is -1 to 1 inclusive. In terms of repetition and periodicity, sine and cosine values repeat with ever full rotation, that is every 2 pi, or multiples of 2 pi. So sine and cosine both have a period of 2 pi, or they have a periodicity of 2 pi. The tangent function is an odd function. It has asymptotes where cosine of theta is equal to 0. And the domain will look like -3 pi over 2 to pi over 2 union -pi over 2 to pi over 2. And it has a period of pi. It has a period of pi. So it repeats every pi. In terms of Pythagorean identities, sine squared theta plus cosine squared theta is equal to 1 and 2. Second one is 1 plus cotangent squared theta is equal to cosecant squared theta. The third one is 1 plus tan squared theta is equal to secant squared theta. Now, we need to remember that sine squared theta plus cosine squared theta is equal to 1. To get this second one, you can take this first identity and divide it by sine squared of theta, and you will get the second identity. And in order to get this third one, it is the first identity all divided by cosine squared theta. Okay, let's look at example. Use the Pythagorean identities to simplify this function. Tan of -3t minus tan of 3t plus pi. And what we know is that tan is an odd function. Remember, in odd functions, f of -x was equal to -f of x. So if you think of x as a 3t, then the tan of -3t was equal to -tan of 3t. So we replace our tan of -3t with -tan of 3t. Also, because the tan function is periodic, then the tan of 3t plus pi is equal to the tan of 3t. So replace the tan of 3t plus pi with tan of 3t. So we put -tan of 3t minus tan of 3t gives you -2 tan of 3t. Now the next example, use Pythagorean identities to write the expression as an integer. What we know is that based on our third identity, or our second identity rather, we have 1 plus cotan squared theta is equal to cosecant squared theta. Now if we let theta be equal to 2 alpha, because 2 alpha is our input, or 2a is our input, then if we plug this in, we have 1 plus cotan squared 2 alpha is equal to cosecant squared 2 alpha. If we want to plug in 1 plus cotan squared 2 alpha for cosecant squared 2 alpha, then what we can do then is have this as 1 plus cotan squared 2 alpha minus cotan squared 2 alpha and then these two will undo each other, so they drop out. So our final answer is equal to 1. Okay, and so that is how you do it. All right, thanks for watching, and please remember to like and subscribe, and see you next lesson.